So as you can see, a square root has been used in this subject. And 8th grade especially is the time when square roots and squares are being used regularly by students, and they learn what I call is demystification of the square root and square. So they learn how different squaring and square root is to all the other operations that they've done before. And next, sophism is a great example for that. I want to introduce Jonah. And Jonah always struck me as a student with great interest to every challenge there is, and also a student with a great ability to put this logic into very precise words or writing. So enjoy Jonah and a complicated sophism. But before we start, I need to attract your attention to this formula in the corner. He is going to use that in his proof. As all the formulas in our math class, they are being derived by students themselves. No formulas are just given to them to memorize, but actually they derive all the formulas. So this formula has been derived in our class, and Jonah is going to use it. Welcome, Jonah.
So, like she just said, I'm Jonah, and I'm going to be presenting another sophism. But this time, I will be proving that all numbers are equal to one another. So we start with the statement. Oh, yeah. A squared minus 2ab plus b squared equals a squared minus 2ab plus b squared. This is obviously equal because both of these statements are the same. For the next step, we're going to rewrite it. A squared minus 2ab plus b squared. But this time, we're going to flip around some terms and get b squared minus 2ab plus a squared. Next, using this formula, we're going to turn these into a minus b squared equals b minus a squared. Then I'll take the square root of both sides and get a minus b equals b minus a. Next, I'll add a to both sides and get 2a minus b equals b. Then I'll add b to both sides and get 2a equals 2b. Finally, I'll divide both sides by 2 and get a equals b, thus proving that all numbers are equal. Now, there is actually a problem with this, I know, right?
What?
If we go through each step, we can find out where the problem is. In this step, these are both the same statement, so it's definitely equal. This step, it's just rearranged. This step, we found this formula, which we know is right. But something about this looks a bit weird. So I'm going to try putting just random numbers in. So I'll put in 3 as A and 4 as B. So 3 minus 4 equals 4 minus 3. And for that, we get negative 1 equals 1, which definitely is not true. So in the transition from this to this, there must be some sort of issue. So to find that issue, let's put the same numbers, 3 is A and 4 is B, into this. Then we'll get 3 minus 4 squared equals 4 minus 3 squared. So if we solve this, we'll get negative 1 squared which equals 1, and 1 squared, which equals 1. So this one is definitely right. So the problem is the transition. And the problem in that transition is that when you take the square root of any number, the answer can be either negative or positive. So like for the square root of 4, it can be 2 or negative 2, because negative 2 times negative 2 is positive 4. So when we take the square root of both of these, the answer can be negative or positive. So let's say that when we take the square root of this side, we get a minus b. That would be positive. We could also get minus a minus b, which, if we factor out, would be minus a plus b. So let's look at this one. For positive, we could get b minus a. And for negative, we could get minus b minus a, which turns into minus b plus a. Now, if we rearrange these terms, we'll see that this is the same, and this is the same. So what it's showing is that when you take the square root of both sides, you have to make sure that they are actually equal and not like this.
Thank you, Jonah. And I totally understand that this is complicated. And actually, the next one will be even more complicated. But I clearly remember how, when I delivered this proof, 8th graders looked at that, copied it down, thought about it, maybe forgot about it. But exactly the next day, Jonah came back to me and said, take numbers and this will not work. So Jonah has demonstrated clearly how strong his critical thinking is. And